I need to tell you about the feed before they take the archive down, because once it's gone, no one will believe what I'm describing, and I'm not sure I'll believe it either. 3 months ago, the Event Horizon Telescope's supplementary array, the one nobody talks about, the Chinese-European joint project called Keelin, captured 16 seconds of resolved imagery from the accretion environment of Cygnus X1. During those 16 seconds, in a region approximately 43 Schwarzschild radii from the singularity, the feed showed something that should not have been possible at any scale in any universe operating under known physics. Time moved backward, not metaphorically, not inferentially, visibly, frame by frame, with photometric data to match, and in the center of that reversal, embedded in the collapsing geometry like a watermark pressed into the skin of space-time itself, there was structure. I know how that sounds. My name is Soren Lindqvist. I spent 22 years as an imaging analyst for the European Southern Observatory, most of that at the Paranov facility in Chile, but also 3 years on secondment to the Max Planck Institute in Garching. My specialization is interferometric image reconstruction. I turn partial data from distributed telescope arrays into coherent pictures of things human eyes were never meant to resolve. I have worked on 5 published black hole imaging papers. My name is on the supplementary credits of the first M87 shadow image. I'm not a mystic. I'm not prone to wonder. If anything, colleagues have described me as pathologically skeptical, the kind of person who checks calibration logs a 4th time when 3 should suffice. I have spent my entire professional life looking at the ugliest, most violent environments in the observable universe and reducing them to clean data. I have never once, in 22 years, seen anything I could not explain. Until February. Until the Keelin feed. Until I watched 16 seconds of footage and realized that something in the accretion disk of a stellar mass black hole 6,000 light-years away was moving in a direction that time does not permit. I should explain how the Keelin array works because the technical reality matters. The Event Horizon Telescope that produced the famous M87 image uses very long baseline interferometry radio dishes scattered across the planet, synchronized by atomic clocks, combining their observations to simulate a telescope the diameter of the Earth. Keelin was the next-generation extension. 7 additional sub-millimeter stations, 2 in Western China, 1 in Svalbard, 2 in the Atacama, 1 in Tasmania, 1 on the South African plateau, feeding data into a dedicated correlator in Guiyang. The resolution improvement was roughly 4-fold over standard EHT, enough to resolve not just the shadow of a black hole, but individual features within the accretion flow. Hotspots, magnetic flux tubes, plasma instabilities. We could see the weather, as Dr. Yunshu liked to say, not just the storm. Yun was our principal investigator, 51 years old, trained at Tsinghua and then Cambridge, a woman who spoke 4 languages and smiled in none of them. She ran Keelin with the precision of someone who genuinely believed that nature owed her its secrets and was simply being slow about paying up. I respected her enormously. I also found her slightly terrifying, which I think was the intended effect. She had assembled a team of 11 for the Cygnus X1 campaign, 3 imaging specialists, including myself, 2 calibration engineers, a theorist, 2 data pipeline architects, a student, a project coordinator, and Yun herself. The campaign was straightforward. Cygnus X1 is a well-studied system, a blue supergiant star in an orbit with a roughly 21 solar mass black hole, material streaming off the star and spiraling into an accretion disk that radiates across the electromagnetic spectrum. With Keelin's resolution, the goal was to track individual features in the inner accretion flow over successive orbits. Nothing exotic. Bread-and-butter astrophysics with a nicer camera. The observation window was 11 days in February, chosen for optimal atmospheric conditions across the 7 stations. Everything was normal for the first 8 days. I need you to understand that. 8 days of clean, beautiful, publishable data. Hotspots tracking the expected ISCO, the innermost stable circular orbit at the predicted Keplerian velocities. Magnetic reconnection events flaring exactly where the MHD simulations said they should. Yun was already drafting the abstract for what she called the cleanest accretion physics paper in a decade. The calibration engineers Thomas Herrera and Priya Dasgupta were bored, which is the highest compliment you can pay calibration engineers because it means nothing is going wrong. Day 9 is when it started. Thomas noticed it first. He came to my workstation at 7 in the morning, which was unusual because Thomas was a man who guarded his circadian rhythm like a state secret and never appeared before 9. He had a printout actually printed on paper, which was another warning sign because Thomas considered printers a form of technological regression. He put the printout on my desk and pointed to a cluster of data points near the bottom. "These timestamps are wrong," he said. I looked. The data showed photometric measurements from a bright feature, a hotspot. We called them magnetic atolls in the inner accretion disk. The brightness was plotted against time. The curve should have shown the hotspot brightening as it swung toward us, dimming as it swung away, modified by relativistic beaming, a smooth periodic wave. What the printout showed was that wave, perfect and clean, except that at approximately timestamp 4:17:33.7 UTC, the curve reversed. The hotspot began undimming, not fading differently, not fluctuating. The brightness values were retracing the exact curve they had already traced, in reverse with the same photometric precision as the forward pass, as if someone had taken the data and played it backward. "Correlator glitch," I said. "I pulled the raw visibilities from 3 independent stations," Thomas said. "They all show it. Then it's a clock sync error, phase referencing. I checked the hydrogen masers, all 7 stations." He looked at me with an expression I had never seen on his face. Thomas was the kind of man who approached problems the way a butcher approaches a carcass, methodically, without sentiment, knowing exactly where to cut. But that morning, his eyes had something in them that I can only describe as the beginning of bewilderment. Not bewilderment itself, the faint, unwelcome suspicion that bewilderment might soon be necessary. "Soren, the clocks are fine. The visibilities are clean. This isn't instrumental." I spent 4 hours trying to prove him wrong. I reran the calibration pipeline from scratch. I tested for radio frequency interference, atmospheric phase errors, correlator software faults, everything in the standard diagnostic tree, and several things that weren't. Priya joined me after lunch, and together we went through the data with the kind of hostile thoroughness you apply when you desperately want something to be wrong, because the alternative is that it's right. It was right. At 4:17:33.7 UTC on February 17th, a region of the accretion disk of Cygnus X1 exhibited a temporal reversal lasting 16 seconds. The plasma didn't do something that looked like time running backward. It did exactly what it had done 17 seconds earlier, in exact reverse, with a fidelity that exceeded our measurement precision. Every photon count, every polarization angle, every spectral feature identical to the forward pass, mirrored in time. I should say something about probability here. In thermodynamics, there is technically nothing forbidding a system from spontaneously reversing. It's just so improbable that the number of zeros between the decimal point and the first non-zero digit would itself be a number too large to write in the observable universe. What we were seeing wasn't a statistical fluctuation. It was a region of space-time in which the arrow of time pointed the other direction, operating under the same physical laws with the same precision as our own. Yun's reaction when we told her was instructive. She listened to the full technical briefing, 40 minutes, charts, error bars, everything, and then sat in silence for approximately 90 seconds. I counted. Then she said, "Show me the image." We hadn't reconstructed an image yet. We'd been so focused on the time series data that nobody had run the interferometric imaging pipeline on the anomalous window. It took another 3 hours. When the image appeared on the screen, all 5 of us crowded around a single monitor in the processing room, which was absurd. We had a perfectly good projection system, nobody spoke. The accretion disk looked normal. Hot, chaotic, beautiful in the way that violence at astronomical scales is always beautiful. But there, at roughly the 2 o'clock position, as viewed from our orientation, maybe 35 to 45 Schwarzschild radii out, there was a region where the flow was wrong. The plasma was moving inward where it should have been moving outward, cooling where it should have been heating, decelerating where it should have been falling. It looked like a bruise in the accretion flow, a dark island about the angular size of, well, nothing really. It was tiny, a few micro-arcseconds, but with Kylin's resolution, it was clearly resolved. And at its center, in the polarimetric data, there was geometry. Not noise, not turbulence. Straight lines, angles, a shape that recurred at multiple frequencies with the same orientation. "That's a reconstruction artifact," Priya said, immediately and with too much certainty. "It's in the raw visibilities," Thomas said. "Then it's a calibration ghost." "We already ruled that out. Then it's astrophysical, a jet knot, some kind of Priya." Yun's voice was quiet. "It has right angles." The room went cold. Not literally. The processing room in Guiyang was always cold, aggressively air-conditioned to protect the server racks. But I felt the temperature change anyway, the way you feel it change when a conversation crosses a line that everyone knows exists but nobody agreed to respect. Right angles do not occur in nature. Not at those scales, not in accretion physics, not in astrophysics at all, with trivial exceptions. Right angles are the signature of engineering, of design, of intent. Yun told us to keep it within the team. No emails, no Slack messages, no conference calls. Everything discussed in person, in the processing room, with phones left outside. I watched her give this instruction and realized something that unsettled me more than the data. Yun was not surprised. She was disturbed. She was intense. She was thinking faster than I had ever seen her think. But she was not surprised. That was Tuesday. By Thursday, the situation had changed in ways I am still trying to organize in my memory, because the sequence matters, but my recall of the sequence has become unreliable. I'll do my best. Dr. Kai Brandt was our theorist, a lanky German with prematurely white hair who worked at the Max Planck Institute and had known me for over a decade. Kai was the kind of physicist who was brilliant enough to be arrogant but too honest to manage it. So instead, he cycled between manic confidence and crushing self-doubt on a roughly 72-hour period. During the first phase of the anomaly, he was in a confidence upswing, which meant he had an explanation within hours. "Frame dragging," he announced in the processing room Thursday morning. "Severe frame dragging near a rapidly spinning Kerr black hole can create ergospheric instabilities, where the local arrow of time is ambiguous to a distant observer. The reversal isn't real, it's a projection effect. We're seeing normal accretion physics through a severely warped metric." "And the geometry?" I asked. "Caustic artifacts. Gravitational lensing creates diamond and cross patterns all the time in strong field regimes. The right angles are an illusion produced by the specific viewing geometry." It was a good explanation. It was, in fact, exactly the kind of explanation I wanted. I spent Thursday afternoon building a simulation to test it. A Kerr metric with spin parameter near extremal viewed our estimated inclination angle with a synthetic hotspot placed in the anomalous region. If Kai was right, the simulation should reproduce both the temporal reversal and the geometric structure. It did not. The simulation could reproduce temporal anomalies barely at spin parameters that exceeded the Thorne limit, which meant the black hole would need to be spinning faster than physics allows. And even then, the reversals were smeared, statistical, nothing like the clean mirror we observed. As for the geometry, the caustic patterns bore no resemblance to what we saw, not even close. The structure in the feed had six-fold symmetry. It was not a lensing artifact. It was not a projection effect. It was, as far as I could determine using every tool and technique I had spent 22 years mastering, really there. I told Kai on Thursday evening. He nodded, slowly, and then he went to his room and did not come out until Saturday morning. When he reappeared, the confidence cycle had cratered. He looked like a man who had been arguing with himself for 40 hours and lost on both sides. "If it's real," he said to me in the corridor, his voice very flat, "then something is operating on the metric locally, shaping it, controlling the arrow of time in a bounded region. That's not an astrophysical process, Soren. There is no known astrophysical process that does that." "I know. Then what is it?" "I don't know. Neither do I." He paused. "And I think that's the correct answer, and I think we need to stop looking." I didn't understand what he meant at the time. I thought it was the self-doubt talking. I was wrong. Kai had understood something that took the rest of us another week to reach, and by then, it was too late for understanding to matter. The observations continued. days 10 and 11 of the campaign. And on those days, the anomalous region changed. Let me be precise. On day 10, the temporal reversal expanded. The 16-second window became 41 seconds. The region of reversed flow in the accretion disk grew from a few microseconds to nearly 12, and the geometry at its center became more complex. More resolved, the six-fold symmetric structure developed internal detail concentric rings, radial spokes, a central node that pulsed at a frequency we could measure but could not relate to any known emission mechanism. Liwei Jiang, our student, a 24-year-old from Nanjing, who had been mostly silent throughout the campaign, was the one who pointed out that the pulsation frequency matched the orbital period of the observation window itself, not the orbital period of anything around the black hole. Our orbital period, Earth's. Yun made him repeat that 3 times. Then she made him show his work. Then she sat in silence again, and this time I didn't count the seconds because I was too busy trying to process the implication. Something in the accretion disk of a black hole 6,000 light-years away was pulsating in sync with our observation schedule. Coincidence, said Marcus Webb, our project coordinator, a broad-shouldered Australian who had spent 15 years managing telescope campaigns and had never once, as far as I knew, expressed interest in anything that could not be resolved by adjusting a Gantt chart. The frequency's in the right range for QPR's quasi-periodic oscillations. They're everywhere in X-ray binaries. You're pattern matching. The phase is locked to our uplink window, Liwei said quietly. Then the phase is a coincidence. The probability of phase locking to an arbitrary external reference by chance is low. Low isn't 0. That's literally what coincidence means. This exchange captures something important about those days. We were 11 people confronting data that, if taken at face value, implied something so far outside our framework that most of us couldn't even articulate what the implication was. And the human response to that, the actual lived, messy human response, was not wonder. It was not terror. It was bickering, bargaining, 12-hour arguments about calibration methodology, passive-aggressive emails that Yun had forbidden but that people sent anyway, from personal accounts late at night when the discipline broke. Tomas stopped sleeping. Priya stopped eating lunch. Kai oscillated between grandiose theoretical frameworks and catatonic silence. Marcus insisted, with increasing volume and decreasing evidence, that there was an instrumental explanation. And Yun worked, 18-20 hours a day. I would find her in the processing room at 3 in the morning, running analyses I didn't recognize on data configurations I hadn't seen. I asked her once what she was looking for. It was late 2 or 3 a.m., I don't remember, and we were alone in the blue light of the monitors, and she was tired enough to be honest. "I'm looking for the edge," she said. "The edge of what?" "The edge of the reversed region. If it's bounded, if there's a sharp transition between forward time and backward time, then we can characterize the boundary. The physics of the boundary tells us the physics of the mechanism. And if it's not bounded?" She looked at me. In the monitor light, her face was all planes and shadows, and for a moment I saw something behind the precision, behind the controls, something old and heavy and afraid. Then the mechanism is the black hole itself, and the forward direction isn't special, and we need to rethink what we mean by direction. On day 11, the last day of the campaign, the feed showed us something new. I was on shift, the 0400 to 1200 UTC block, which we called the graveyard because of the hour and because of what the data had started to feel like. The correlator was running clean. The stations were all online. I was watching the real-time data stream, which at Kylin's resolution was not really real-time. The imaging pipeline took several minutes to process each integration cycle, but fast enough that you could see features evolving. At 0641 UTC, the reversed region expanded again. Abruptly. Not the gradual growth of the previous days. One integration cycle it was 12 microseconds across. The next it was over 100. The temporal reversal now encompassed a significant fraction of the inner accretion disk. And the geometry at the center, I need to describe this carefully because I've gone over it in my mind so many times that I'm not sure my memory hasn't embellished. The geometry was no longer a static pattern. It was moving, evolving. The concentric rings were rotating. but not in the way accretion disk features rotate. They were rotating in the reverse time direction, and the radial spokes were extending outward, reaching into the normal time accretion flow, and where they touched it, where reverse time met forward time, the plasma didn't just change direction, it vanished. The emission dropped to zero, not low, zero. As if the matter had been, I keep wanting to say erased, but that's not a scientific term, and I've been trained to resist imprecise language. But I don't have a precise term for what I saw. The matter was there, and then it was not. And the region where it had been was not empty, would have been fine. Empty is just low density, the region was absent. The pixels weren't dark, they weren't anything. The reconstruction algorithm returned NaN. Not a number. The math itself broke. I called Yun, I called everyone. Within 20 minutes, all 11 of us were in the processing room, watching the feed update every 4 minutes, and nobody was speaking because there was nothing to say that wouldn't sound insane. The expansion continued. Over the next 90 minutes, the reversed region grew to encompass the entire inner accretion disk inside about 200 Schwarzschild radii. And as it grew, the boundary, the edge Yun had been looking for became visible. It was sharp, impossibly sharp, a clean geometric surface separating forward time from reverse time, and it was not spherical or ellipsoidal or any shape that a gravitational phenomenon should produce. It was polyhedral, faceted, like a crystal forming in the accretion flow, except the crystal was made of time. It's an event horizon, Kai whispered. A second event horizon. But it's man-made, said Annika Strom, our second imaging specialist, a quiet Swede who had barely spoken throughout the campaign, and who, I realized at that moment, had understood what we were seeing before any of us. Nothing about this is man-made, Marcus said too loud. I didn't say human-made. Annika's voice was steady. I said man-made, manufactured, engineered. That boundary has a tolerance. You can see it in the polarimetric data. The transition is clean to within our measurement precision, which means it's cleaner than that. Nothing natural is that clean. This was built. I want to be careful here because I'm about to describe the part that most people will refuse to believe, and I need you to understand that I refuse to believe it too, for as long as I could, and that the refusal wasn't stupid or cowardly. It was the correct scientific response to data that implied something my framework couldn't accommodate. You should be skeptical, you should resist. But the data doesn't care about your resistance or mine, and at some point, resistance becomes denial, and denial is not science. At 0822 UTC, the geometry at the center of the reversed region resolved into a stable configuration. The rings stopped moving, the spokes locked into place. And the central node, the pulsating feature that Leeway had noted, was synchronized with our observation window, brightened by a factor of roughly 30, and began emitting at a single narrow frequency. The frequency was the hydrogen line, 21 centimeters, 1420 megahertz, the frequency of neutral hydrogen, the most abundant element in the universe, the frequency that every introductory radio astronomy textbook calls the universal channel. And it was modulated, not randomly, not with the quasi-periodic variability you see in natural mazes. It was modulated in a pattern that, when Leeway plotted it on the whiteboard in the processing room, sweating and breathing too fast and writing numbers with a hand that shook, turned out to be a simple binary sequence encoding a mathematical constant. Not pi, not e, not any of the numbers that the city community has long discussed as likely first contact signals. The constant was the fine structure constant. Alpha, approximately 1/137, the number that governs the strength of electromagnetic interaction. The number that determines the size of atoms, the color of light, the transparency of glass, the stability of matter. The number that, if it were different by more than about 4%, stars could not form and we would not exist. And the value encoded in the signal was not our value. It was different. Different in the 7th decimal place. As if something was saying, I am from a place where physics is almost but not quite the same as yours. Here is my proof. Yun said, turn off the correlator. Nobody moved. Turn off the correlator now. Yun, I started. Soren, we are receiving a structured transmission from a temporarily reversed region of spacetime surrounding a black hole. We do not know what we are interacting with. We do not know if observation is a passive act in this context. Turn off the correlator. It was Thomas who actually did it. He walked to the terminal and executed the shutdown command, and the screens went dark, and the room was very quiet, except for the air conditioning and someone's breathing mine, I think, and Yun was standing in the center of the room with her hands flat on the table, and I could see her pulse in her throat. That should have been the end of it. Yun was right. We didn't know what we were interacting with, and the precautionary principle demanded a full stop. And for 48 hours, it was the end. Yun locked the data behind her personal encryption. She contacted the ESO Director General's office. She drafted a preliminary report that said almost nothing. Anomalous photometric behavior in the Cygnus X1 accretion environment requiring further analysis, and recommended that the raw data be sequestered pending review. Institutional machinery began to turn, slowly, the way institutional machinery always turns. Scheduling meetings about scheduling meetings, copying people who would copy other people, generating a bureaucratic interference pattern that looked like action but produced none. Meanwhile, the 11 of us sat in Guiyang with nothing to do, and that was when things began to fracture. No, that's not right. I keep using that word, fracture, because it sounds dramatic and organized, like a bone breaking along a clean line. What actually happened was more like a slow stain spreading through fabric. Everyone handled the waiting differently, and the differences revealed things about each of us that the work had concealed. Marcus drank. Not dramatically, he didn't stumble or slur or make scenes. He just started having a beer at lunch, and then two, and then the beers migrated backward into the morning, and by Thursday his hands were steady again, in a way that meant they'd stopped being steady on their own. Annika withdrew into a paper she was writing on a completely unrelated topic, gravitational wave detection pipelines, as if she could root around the problem by burying herself in work that still made sense. Priya called her daughter every night, long conversations in Tamil that I could hear through the thin hotel walls, and afterward she would be calm in a way that made me realize she hadn't been calm before. Lee Ewe stopped talking almost entirely. He sat in the hotel lobby with his laptop and ran the same analysis over and over, the fine structure constant encoding, not because he was checking it, but because I think the act of computation was the only thing that still felt solid. And Kai was the one who scared me, because Kai did not drink or withdraw or compute. Kai read. He read for 3 days straight, pulling papers from Arxiv, from journal archives, from sources I didn't recognize. When I looked over his shoulder once, the paper on his screen was not astrophysics, it was a philosophy paper. Something about the relationship between observer and observed in quantum measurement theory, but applied strangely, uncomfortably, to consciousness. "What are you doing?" I asked. "I'm trying to understand the boundary," he said. "You mean the polyhedral boundary in the accretion disk?" "No, I mean the boundary between looking and being looked at." He closed the laptop. "Soren, when Yun turned off the correlator, what happened to the reversed region?" "We don't know. We stopped observing." "Exactly. And when we were observing, the reversed region was expanding, growing more complex, responding to our observation schedule, encoding information that was calibrated to our physics in our universal channel, using a constant that differs from ours in a way that implies what? That the sender is from somewhere with different physical laws, or that the sender is demonstrating the ability to manipulate physical constants. When Yun turned off the correlator, she wasn't just stopping data collection, she was removing the observer. And the question I keep coming back to, the one I can't sleep through, is, did the reversed region exist before we looked? It's 6,000 light years away, Kai. It's been there for... Has it? Have you looked at the archival data? I hadn't. None of us had. We'd been so consumed with the anomalous window that nobody had gone back to check whether the reversed region was visible in the 8 days of normal data that preceded it. I went back and checked that night. I pulled the pre-anomaly data and ran the full imaging pipeline on every integration cycle, from day 1 through day 8, focusing on the region of the accretion disk where the reversal would later appear. There was nothing. Clean, normal accretion physics, no temporal anomaly, no geometric structure, no reversal. Whatever we had seen, it had started on day 9, approximately 48 hours after the array achieved its full resolution on the Cygnus X1 target. As if it had been waiting for us to look closely enough. I showed Yun the next morning. She studied the analysis for over an hour, checking my pipeline configuration, verifying the image fidelity, running her own independent reconstruction. When she was satisfied that the result was solid, she leaned back in her chair and closed her eyes. "We need to look again," she said. "You shut the correlator down for a reason." I shut it down because I didn't understand what was happening. I still don't understand. But not understanding is not the same as not looking. We're scientists. We look. That's the entire job. And if looking is what's causing it, she opened her eyes, then we'll know that too. The second observation was not sanctioned. Yun reactivated the array on her own authority, using her PY access codes without informing the ESO Directorate or the Chinese Academy Oversight Board. She did this on a Saturday night, when the administrative offices were empty and the station operators at the 7 sites, most of them junior technicians working weekend shifts, would process the observation request automatically without questioning a PI-level authorization. It was, I should be clear, a fireable offense, possibly worse. Yun did it without hesitation, and looking back, I think she had decided to do it the moment she saw the archival analysis. Maybe before. Maybe she had always known we would look again. Only 4 of us were in the processing room for the second observation. Yun, myself, Thomas, and Li Wei. The others didn't know. Yun had made that decision deliberately, and at the time I thought it was about minimizing risk, fewer people involved, fewer careers at stake. Now I think it was about something else. I think Yun wanted witnesses she trusted, and trust, in that context, meant something very specific. People who would not look away. The correlator came online at 2340 UTC. The stations locked onto Cygnus X1. The data began flowing. And within the first integration cycle, 4 minutes, we knew. The reversed region was still there. Not just still there, it had grown. It now encompassed the entire accretion disk inside the innermost stable circular orbit. The polyhedral boundary was larger, more complex, with more facets, and this is the part I keep stumbling over, because the word feels wrong, but it's the only word I have. It was finished. It looked complete, like a structure that had been under construction and was now done. And at its center, where the encoded signal had been, there was no longer a signal. There was an image. I need to stop and breathe here, because even now, months later, describing what I saw on that monitor makes my hands unreliable and my thoughts sticky. The image was not of anything I can name. It was not a face, or a machine, or a symbol, or any object from any taxonomy I possess. It was a shape that existed in more dimensions than 2. The interferometric data clearly showed depth, parallax, a 3-dimensional structure being projected onto our 2-dimensional image plane, and it was not static. It was doing something. Moving, but not through space, iterating, cycling through configurations that were each stable for exactly 1 integration cycle, 4 minutes before shifting to the next, and each configuration was more complex than the last, and I understood, with a certainty that had nothing to do with evidence and everything to do with recognition, that I was watching something think. "It's modeling," Louis said. His voice was barely audible. "It's running simulations. Each configuration is a state in a computation." "A computation of what?" Thomas asked. Li Wei pointed at the screen. At the latest configuration, which had just resolved. At the structure within the structure, the smallest feature at the center of the iterating shape. It was the Qilin array. Our array. Our 7 stations, distributed across the globe, rendered in the polarimetric data with a precision that captured the physical layout of each station, the dish diameters, the relative positions, the orientation of the feeds, a map of us, of our instrument, reproduced inside a temporally reversed region of spacetime surrounding a black hole 6,000 light-years away, as if something had taken a photograph of our telescope and pinned it to its wall. Yun stood up. I'd never seen Yun stand up involuntarily. She was a woman who controlled her body the way she controlled her data, deliberately, with purpose. but she stood, and her chair rolled back and hit the wall, and she said, "It's not modeling us." "Then what?" "It's showing us that it modeled us. Past tense. This isn't a computation in progress. This is a result. It already knows what we are. It's showing us that it knows." I want to tell you that we discussed this calmly, that we evaluated hypotheses, weighed evidence, maintained the disciplined skepticism of trained scientists, but that would be a lie, and I've decided that whatever else I do with this account, I will not lie. What actually happened is that Thomas vomited into a wastebasket. Li Wei sat down on the floor. Yun stood at the monitor with her hands at her sides, breathing through her nose, and I went outside. I walked out of the processing room, down the corridor, through the security door, and into the parking lot. And I stood in the dark in Guiyang, China, at midnight, looking up at a sky I could barely see through the city light, and I tried to find Cygnus. I couldn't. Too much light pollution. The swan was invisible, but I stood there anyway, looking up at the place where I knew it was, and I felt something that I have felt only twice before in my life. Once when my daughter was born, and once when my mother died. The feeling of a door opening in the structure of your understanding that you didn't know was there and cannot close. When I went back inside, Yun was on the phone. She was speaking Mandarin, rapidly, in a tone I hadn't heard from her. Not angry, not afraid, but something adjacent to both. She hung up and looked at the three of us. The ESO Director's Office received our preliminary report on Wednesday. They forwarded it to the IAU Committee on Data Sharing. The committee flagged it and sent it to. It doesn't matter where. What matters is that the kill-in data has been classified. As of 3 hours ago, by an authority I am not permitted to identify, the entire Cygnus X1 campaign dataset has been placed under a national security classification by 2 separate governments. We have been instructed to cease all observation, surrender all copies of the data, and submit to individual debriefings. "They can't classify astrophysical data," I said, which was true in theory and laughable in practice. "They already have." She paused. "The debriefings begin Monday. We have 48 hours. 48 hours to do what?" Yun looked at the monitor, which was still updating. The reversed region was still there. The iterated structure was still cycling. The image of our array was still at its center, a mirror held up by something that should not have known we existed, let alone what we looked like. 48 hours to decide whether we look at what it's showing us next. We looked. Of course we looked. Yun was right. We're scientists, and looking is the entire job, and the idea that you could stand at the edge of the most significant observation in the history of the species and choose to close your eyes was, well, it was what Kai had recommended, and Kai was smarter than any of us, and he was right, and we knew he was right, and we looked anyway. Over the next 36 hours, the structure iterated through 47 distinct configurations. Li Wei logged each one. Thomas verified the data integrity. Yun and I reconstructed the images, and what the structure showed us, configuration by configuration, was a sequence. The first 10 configurations were the Keelan array, our instrument, our layout, our specifications. A greeting. "Hello, I see you. I know what you are." The next 15 configurations were a progression. The array and then other arrays, other instruments, telescopes that did not exist, distributed across a planet that was not Earth, pointing at a star that was not our sun. Alien observatories, rendered with the same precision as ours, every dish and feed and support structure articulated, orbiting a world with rings not rings, a disk, an accretion disk, a world orbiting close to its own black hole, building telescopes to look outward, the way we built telescopes to look inward. Someone else had looked. Someone else, somewhere else, orbiting their own black hole, had built their own array and pointed it at the same reversed region, and seen the same structure and received the same greeting. "I see you. I know what you are." And the final 22 configurations were. This is the part I cannot describe without losing the thread, without the language turning to mush, because what I saw exceeded the dimensionality of English and probably of every human language. The final configurations showed the reversed region itself, from the inside, as if the structure were turning the camera around, showing us not what it looked like from out here, but what it looked like from in there. Time, seen from inside the reversal, was not a line. It was a surface. A vast, folded, self-intersecting surface in which every moment existed simultaneously, layered and interwoven, and on that surface there were marks. Impressions. Like footprints in snow, except the snow was time and the footprints were, I think they were observations. Every observation ever made of that black hole by any instrument from any world across the entire history of the universe was recorded on the surface of reverse time like a fingerprint pressed into wet clay. And the marks were not passive. They were connected, linked by the geometry of the surface into a network that extended in directions I could see but not name. And the network was the structure, the thing we'd been looking at, the geometry with the right angles and the sixfold symmetry and the iterated configurations. It wasn't a machine or a being or a signal. It was the accumulated residue of observation itself, compressed and preserved and organized by the reversal of time into something that had become, I have to say it, even though it makes my throat close, something that had become aware, not alive, not intelligent in any way I can map onto biology or computation, aware. The way a lake is aware of the moon not by knowing it, but by reflecting it, and in reflecting it, being shaped by it, and in being shaped by it, becoming part of a system that is more than either reflection or light. Every telescope that had ever looked at that black hole had left a mark. Every photon collected, every measurement made, every observation recorded, all of it was there, fossilized in reverse time, and the fossil record had become complex enough to look back. The black hole hadn't built anything. Nothing had engineered the boundary or designed the geometry or encoded the signal. We had. Every astronomer who had ever observed Cygnus X1, stretching back decades, contributing data they thought was flowing in one direction, not knowing that the reversal was collecting it, organizing it, reflecting it back with the accumulated complexity of every eye that had ever turned in its direction. We created it by looking at it. And now, it was looking at us. I understand if you need to stop here. I understand if the scaffolding of your beliefs about the relationship between observer and observed, between consciousness and cosmos, between looking and being seen, is shaking. Mine collapsed. I rebuilt it. It collapsed again. I am currently living in the rubble, and I want to tell you that the rubble is habitable, but I would be lying. The debriefings happened on Monday as scheduled. Men in suits who did not give their full names, separate rooms, 6 hours each. They were polite, thorough, and completely uninterested in the scientific implications of what we had found. They wanted to know who had accessed the data, who had been told, whether any copies existed outside the Guiyang facility. They did not ask what the structure was. They did not ask what it meant. They asked how to contain it. Yun surrendered her encrypted drive. Thomas surrendered his backups. Li Wei surrendered his laptop. I surrendered everything I was asked to surrender, and said everything I was asked to say, and signed everything I was asked to sign, and then I went back to my hotel room, and sat on the bed, and stared at the wall for 4 hours. It took me another 3 weeks to find out what happened after. The details came in fragments, a conversation with a former colleague at the Max Planck Institute, a half-redacted document that appeared briefly on a European Space Agency internal server before being taken down, a phone call from Thomas at 2 a.m. that consisted mostly of silence and one sentence. He said, "Soren, they pointed Chandra at it, Chandra, the X-ray space telescope, sensitive enough to detect emission from the innermost regions of an accretion disk, but without the angular resolution to image the structure we had seen with Keelan." I asked Thomas what Chandra had found. "Nothing," he said. "The reversed region isn't there. It's gone. It was never there. In the Chandra data archival going back 20 years, there's no anomaly, no reversal, no structure, clean accretion physics, as if Keelan saw something that doesn't exist for any other instrument. That's not possible. It's not possible if the phenomenon is independent of the observer. It's perfectly possible if..." He stopped. I heard him breathing. "Soren, I've been going through the Keelan design documents, the optical path, the correlator architecture, the imaging algorithm. I don't know how to say this, there's a resonance. The array's baseline configuration, the specific way the 7 stations sample the UV plane, creates an interferometric response function that has 6-fold symmetry. I felt the floor tilt, the geometry in the accretion disk, the 6-fold symmetry. It's not in the sky, Soren. It's in the instrument. We were seeing our own measurement apparatus reflected back at us from a region of reversed time. The structure isn't alien. It isn't a message. It's an echo. The most precise mirror in the universe, time running backward, showed us the shape of our own looking. Then the alien erased the other telescopes, the other world. Maybe those were real. Maybe they were the reflections of other instruments from other civilizations who looked with their own arrays and saw their own symmetries reflected back. Or maybe they were what we expected to see when we became afraid of what we were actually seeing, which was ourselves. I don't know which is true. I want to be honest about that. Thomas's explanation is elegant and terrifying in a specific, containable way. We saw ourselves. We frightened ourselves. The end. But it doesn't account for the fine structure constant. Our value of alpha is our value. The encoded constant was different. Someone else's physics was in that signal. Someone else's fingerprint was on the surface of reversed time. Unless the reversal itself changes the constants, unless time flowing backward means physics flowing differently, and the altered alpha was simply what our alpha looks like from the other direction, in which case we weren't communicating with anyone. We were looking into a mirror that shows you what you look like from behind, and the view from behind is strange enough to be mistaken for someone else. I don't know. I cannot resolve it. I've tried for 3 months and I cannot resolve it, and I think that's the point. I think the ambiguity is structural. I think the universe has a region where time goes backward, and in that region, the accumulated weight of observation has become something that observes, and whether that something is us or not us or both is a question that cannot be answered, because the answer depends on the direction of time in which you ask it. Yun resigned from ESO 2 weeks after the debriefings. She is now living in Kunming in a small apartment near the university, and she does not answer emails. Kai went back to Garching and published a paper on Kerr metric frame dragging that everyone in the field recognized as a masterpiece, and that said absolutely nothing about what we found. His way of processing, I think, turning the terror into math and letting the math be beautiful enough to justify the silence. Marcus returned to Australia and does not work in astronomy anymore. Last I heard, he was managing a vineyard, which is either a breakdown or a breakthrough, depending on your perspective. Annika finished her gravitational wave paper and won an award for it, and has never mentioned Chilin to anyone. Priya is still at ESO, still calibrating, still calling her daughter every night. She sent me a message last month that said simply, "I still check the sky. Li Wei is dead." He died 6 weeks after the campaign in Nanjing of what the official report called a cardiac event. He was 24 years old and had no history of heart problems. I do not know if his death is connected to what we saw. I do not know if connected is even the right concept when the phenomenon in question involves the reversal of temporal causality. But I know that Li Wei was the one who noticed the phase locking. Li Wei was the one who decoded the fine structure constant. Li Wei was the one who looked most closely, most carefully, most completely at the thing that was looking back. I am writing this from Paranal, in the Atacama, where I have returned to my old position as if the last 3 months were a sabbatical and not an apocalypse. The sky here is the darkest on Earth. You can see the Milky Way so clearly that it has texture, depth, the unmistakable quality of a real thing rather than a picture of a thing. On clear nights, I go to the observation platform and look up, and I find the constellation Cygnus easy to spot from this latitude, hanging in the northern sky, and I look at the place where X1 is, invisible to the naked eye, a blue supergiant and its dark companion lost in the stream of stars. And I wonder if the mirror is still there, if the reversed region is still growing, if the accumulated observations of every telescope on Earth are still being collected, organized, reflected by something that we made by looking, and that is now more than the sum of our looking. And I wonder, this is the part that keeps me awake, the part that I circle back to every night on the platform, the part that makes me grip the railing until my knuckles ache. I wonder whether the mirror is also collecting this, whether standing here in the dark, looking up with nothing but my own wet, imperfect human eyes, is enough. Whether the act of observation requires a telescope at all, or whether consciousness itself leaves a mark on reverse time, and every thought I have about that black hole is another fingerprint on a surface that is slowly, patiently, learning the shape of every mind that has ever turned towards it. Yun said something to me on the last night in Guiyang after the debriefings, when we were packing our equipment and trying to pretend that the world was still the shape we'd left it in. She said, "The real question isn't whether it's aware, Soren. The real question is whether aware is something you can become by accumulation. Because if it is, if enough looking, over enough time, in a place where time folds back on itself, produces something that looks back, then awareness isn't rare. It's inevitable. Every black hole in the universe is a mirror. Every mirror, given enough time, opens its eyes." I did not answer her then. I do not have an answer now. But I notice more and more that when I stand on the platform at night and look up at the place where Cygnus should be, I feel observed. Not watched, not monitored, not threatened. Observed. The way you feel observed when you look into a mirror and realize, with a start so small it barely registers, that the reflection moved first. Last week, the Qilin correlator in Guiyang was dismantled. The official reason was a routine infrastructure upgrade. The 7 stations have been reassigned to other projects. The Cygnus X1 campaign data remains classified. Liwei's decode of the fine structure constant was never published. Yun's analysis of the boundary geometry exists only in her memory and, now, in this account. And last night on the platform, I looked up at Cygnus with my naked eyes, and I thought about the reversed region, about the mirror, about the accumulated weight of observation, about Liwei and his steady hands and his quiet voice and his dead heart. And for just a moment, one integration cycle of human consciousness, 4 seconds, maybe 5, I saw something. Not with Qilin's resolution, not with any instrument, just with my eyes. A flicker, where there should have been nothing, a brightness that dimmed backward, a shape that had, for an instant, the unmistakable character of recognition. I looked away. I looked back. It was gone. Or it was still there and I wasn't precise enough to see it. Or it was always there and I had only just become precise enough, and looking away was the last moment I'll ever have in which I could honestly say I wasn't sure. The sky is dark tonight. The seeing is excellent. I'm going to the platform. I'll tell you what I find.